So the response of you have either you might have a single stage amplifier or you might have a multi-stage amplifier. So the response will determine, it's determined by the frequency of input signal, what frequency you are going to apply, whether it is low frequency or high frequency. Low frequency, the effect will not be there. The capacitance effect will not be there. Only in high frequency, the capacitance effect will lead to disruption of your circuit. The circuit will not work as you expected it to behave. You see, at low frequencies, the effect of capacitors is neglected due to the high value under these conditions. What they are saying is it cannot be neglected means they will become open circuit. You have to consider them, but the reactance value will be very, very high. It will be open circuit. So it is just like the current will not flow through these capacitors. So it will affect. So if you are going to connect these components between two stages, that is going to affect the frequency response of the system. So at low frequencies, these effect of capacitors, even though it is to be considered, it is going to be open circuit and there will be no effect. But at high frequencies, these effect of capacitors will be very, very predominant and you cannot neglect their effect. You have to seriously consider the effect of these capacitors in the high frequency analysis of your amplifiers. So while plotting the frequency response, mostly see what they have said. It is always a practice to use logarithm scale along the x-axis so that it becomes the frequency will become in logarithm scale and y-axis will be having your normal scale. So x-axis will cover the entire frequency from very low frequency, medium and high frequency, and y-axis will be the value of your gain. Okay. So in general, any frequency response graph can be split into three regions. See here. Here you see it is starting from 10 hertz and we are going till 10 megahertz. So the graph will be like this. It will be increasing. It will be increasing. It will be constant. It will be decreasing. இங்கே ஏன் இன்க்ரீசிங்னா இந்த லோ ஃப்ரீக்வன்சி ரீஜியன் xc is equal to 1 by omega c. Okay, so as the frequency is going to slowly increase, the reactance will decrease. So reactance decrease more amount of voltage will be available and the gain will also be increasing. In the mid frequency region, this capacitive effect will not be there. So gain will be constant. In the high frequency region, as the frequency is very high, this capacitor will behave like short circuit. So whatever input you give, it will go to ground. So output voltage will be slowly decreasing and the gain will also be slowly decreasing. So any frequency response region, we have three regions. One is low frequency. This is your low frequency region, this dotted line. So till this point is your low frequency. And between these two regions is called the mid frequency region. In the mid frequency region, the gain will be constant. Very, very important point to note. Okay, the gain will be constant. After the mid frequency region, you have the high frequency region where the gain sharply declines because of capacitive effect. So the region only in the mid frequency region you have a constant gain and this device will be properly working. Otherwise, you should not operate the device in low frequency region or in high frequency region where the gain is varying. Only in the mid frequency region the gain is relatively it is going to be constant and you can operate the device in the mid frequency region only. The frequency response is plotted between gain and frequency. So see here, magnitude of gain and frequency. Gain is in normal scale, frequency is in logarithm scale. So a typical frequency response of a common emitter amplifier is shown in the diagram. We have seen the different regions. It will be always increasing, constant, decreasing. You will be getting this characteristic only for common emitter amplifier.